Hi, so this session is on calculating the circumference of a circle and also understanding what we mean by pi and how it relates to a circle. Now there are a few keywords we need to first cover to make sure you understand these keywords and how we apply them. The first one is circumference. So if I just draw a quick circle, pretty good. Now, instead of saying the perimeter of a circle, now we know perimeter means the outside of a shape. And we can calculate the perimeter. For example, the perimeter of a rectangle, if it had a length of 7 and a width of 2, we would simply add up all the sides. So that would be 7, that would be 2. So 7 plus 7 is 14, plus 2 is 16, plus 2 is 18. So I would say perimeter is 18. Now for a circle, you can see it's not that easy because it's all curved. And there is a way mathematicians have come up with to calculate the perimeter of a circle. But the first thing is it's called the circumference. So we spell it like this. So from now on, when I say the circumference of a circle, I really mean the perimeter of a circle. And this only applies to a circle. So here's another circle, and the next important point is every circle has a center point. So imagine this is a perfect circle, there's its center, and any line that passes through the center and hits both ends of the circle. So for example, I can do this one in red. So I'll draw a line. So imagine it's a perfectly straight line. See how it's passed through the center? If it passes through the center, that is called the diameter of the circle. This is a very important key word. Okay, so the diameter of a circle passes through the center, but it hits both ends of the circle. So for example, I can do another diameter in green, as long as it passes through the center and hits both ends. Okay, so these two lines are the same length. If I do another one, I can do this one in blue, going down, let's say this way. So far, all these three lines have the same length. They are called the diameter of the circle because they all pass through the center and they hit both ends of the circle. And you can imagine how many diameters there are. There's an endless amount. And think of an oven knob. If I twist one of those lines, imagine the green one, and I twist it, the diameter goes all the way around, and so there's an endless amount of diameters. Now with my next circle, I'm going to draw a line. I can do this one in green. So it hits the center, but it only, out of my circle, it only goes halfway. Now when you see a line like this where it's almost the diameter, but it's only half of it, you can see it hits the center and it hits one end of the circle. This is actually called the radius. So this is another important keyword. And at the end of this session, we'll go through all the dot points that we have covered. So the radius is half of the diameter. And it always hits the center and then it hits one end of the circle. So I can do another radius, hit the center and go to the other end of a circle. Or we can do one more color. And once again, there are an endless amount of radius lines as long as it's only half of the diameter. So let's try a practice question. So here's a quick circle that I've drawn. I want you to tell me what the radius of this circle is. So you should have calculated, well, the radius is half of the diameter. We can see the diameter is given to us. So half of A is 4. So the radius is 4. In this case, 4 centimeters. All right, here's another practice question. What is the diameter of my circle? So you can see that what is given to us is the radius, and we know the diameter is double the radius. So what's 2 plus 2? 4. So for this circle, the diameter would be 4, and the units are meters. Okay, so hopefully that has made sense. So far we have covered 3 keywords that are extremely important. Circumference, which is the outside part of the circle, what we know as perimeter. The diameter, which is a full line that passes through the center and hits both ends of the circle. And last of all, the radius, which is half of the diameter. Now, the next thing we are going to be looking at is this symbol here. And you may have seen it in class or on your calculator. And on our poster in the classroom, there's a poster that instead of that pi symbol, they've got the word pi, P-I, and we call this pi. Now, this is I believe, the sixth letter of the Greek alphabet. I'm pretty sure it's a sixth letter, but it comes from the Greek alphabet, pi. And pi is actually a number. We use a symbol for pi because pi itself, the number, actually never ends, and there is no pattern. And it starts with 3, and then we have a decimal point, 3.14, and it keeps on going and going and going. Students, and sometimes we can round this off to 3.142, so you may see that quite often. That's rounded off, but whenever you round off something, your answer will not be exact anymore. You'll still be close to the measurement. However, when you round off something, it's not going to be exact. So that's why when using pi and calculating the circumference of a circle, it's important that you have a calculator and that you push this button on your calculator. Some models you need to push shift and then pi, others you don't have to push shift. So just have a look and see how to use your own calculator. But instead of typing in 3.142 times whatever, if you have used pi before, I want you to use this symbol whenever you can, because it gives you a more accurate answer. Okay, so understanding pi. So how do we get pi, and what does it mean? And what does this 3, 0.14 and so on, what does this all mean? Now, hopefully at some point you'll be able to do an activity that can prove what I'm going to tell you and help you understand it a bit better. But we'll focus on how we get this actual 3 and what it actually means. Now, if I draw a quick circle, okay, now this circle, if I imagine I cut this circle at one point, if I cut it and straighten it out, what will I end up with? I'll end up with a straight line. So I'll just do that. Now, this won't be accurate, obviously. I'll do my best. Now, so this red line is, imagine I cut my circle, so its circumference, and I've straightened it out. It's supposed to be a nice, perfect straight line. That's all I've done so far. So we know the circumference of a circle, if we cut it, it forms a straight line. That's pretty straightforward. Now, we know every circle has a diameter. So I'll just draw the diameter of this circle. Okay. And when you do this outside, what happens is, if you measure the circumference, so imagine I measured this straight line, and I want to see how many more circles can fit on its own circumference, or how many more circles can fit on this line here. And if I go to draw that, all I have to do is draw the diameter, don't I? So imagine I drew my diameter of another circle, and I drew another one. So I'll try and draw the circle as well. So it's roughly the same length. And I'll do one more diameter. Now this isn't accurate, obviously, but I'm doing the best I can. So now what you notice is how many circles or how many diameters can fit onto its own circumference. You can see that 3 circles can fit on its own circumference. And over here, there's actually a little bit left over. That's why we get 3. It's saying 3 diameters can fit onto its own circumference of any circle. And the reason why we have 0.14 and it never ends is because there's a little bit left over. So you can see this part left over. That's what makes our decimal. So to approximately calculate the circumference of a circle, all we have to do is get its diameter. Just say this circle had a diameter of 10 meters. Okay, so each one had a length of 10 meters. What is the total length of this line? Its circumference. Well, 10 times 3 is going to be 30 meters. So approximately, as a quick guess or approximation, the circumference of a circle with a diameter of 10, in this case 10 meters, is going to be 30 meters. Now, it'll be a little bit more because we have the decimal part, but that's just a quick calculation. So that is what pi actually is. It's telling you that this 3, which is the most important number, is that if you measure your circumference and draw it as a straight line, you will fit 3 circles or 3 diameters of that circle on its own circumference, no matter how big or small your circle is. So hopefully one day you can do an activity that actually proves this. So here are some practice questions. Let's see how we go. So it asks us to approximately calculate the circumference of the following circles. So the perimeter of the circle itself. Now imagine you didn't have a calculator, so you didn't have a pi button to push, and it's asking for an approximate answer. So we know that 3 diameters make up the circumference of a circle. So I will times the diameter by 3. So the first one, my diameter, D for diameter, is what? 12 meters. 12 meters, yep. And as a quick answer, I'll times this by 3. So now I'll end up with C. So circumference is going to be, what's 12 times 3? It's 36. And I'll put my units meters. So instead of an equal sign, so the circumference is approximately equal to 36 meters. Now I know that it'll be a little bit more because we haven't included the decimal part, but as an approximate answer, the circumference of this circle that has a diameter of 12 meters is 36 meters. Let's try number 2. So this diameter I can see is 3 meters. So once again, diameter is 3. So for the circumference, for my approximate answer, I'll times 3 by 3 because I know 3 of those can fit on its own circumference. So C will be equal to 9. Approximately equal to 9 meters. And we're done. Now the last one, they're trying to trick you, and that is what's given to you, the diameter or the radius. Well, you can see that we don't have the diameter, we have the radius. So if I wanted to draw my radius, I'd have another 1 meter here, and 1 plus 1 is 2. So diameter in this one is going to be 2 meters. And once again, I do the same thing. Circumference will be approximately equal to 2 times 3, which is 6 meters. So that's how easy it is to calculate the circumference of a circle, and we're not far off. Now to calculate it as a more exact answer, this is where we use the pi button on our calculator. And there are some formulas we have to learn. So these are the 2 formulas we can use. You can use one or the other, it doesn't matter. When we have to use pi now to calculate the circumference of a circle. Now you notice with the first one, we have actually used it. If you remember in the previous examples, instead of pi, we approximately use what number? We use 3. And we know pi is actually 3, but 3.14, and it goes on to infinity. So instead of just using 3 now, we're just going to push the pi button and times it by D, and D is its diameter, and that's it. Now the other formula, it's the same thing, except instead of D, what do you notice? There's an R here. R means the radius. So if you're given the radius, you can choose to use this formula, and in between everything, there's times. So 2 times pi times R. And why do you think that 2 is there? That 2 is there because it's doubling the radius. Because if we double the radius, we get the diameter. So they're actually the exact same thing. If you just want to use one, and you want to use this one, that's fine. I like using pi times Z, but you have to be careful. If you're given the radius, you must double it first. Okay, always check and see, do you have the diameter or do you have the radius? But it's important to know both because you will come across both. And it's not hard to remember, either pi times D or you double the radius, 2 pi R. So let's try some examples. So for these 3 circles, we have to calculate the circumference of these circles. And this time we are using our calculators and using the pi button. So for the first one, always check and see what is given to us. We can see that it's the diameter. Now, whenever you're calculating circumference or area and you have formulas that you're using, please make sure you write the formula first. So C is for circumference, is equal to, now I'm going to use pi times D because that's it. And you can put times if you want to. And then fill in what we have. Well, we've got circumference equal to pi, and we know pi is not it's not a variable. Pi is actually a number. And the reason why we have to use a symbol is because we can't spend forever writing all the decimals of pi, all the decimal numbers. Okay, times, and what's the diameter? It is 7. And now at this point, get your calculators And you will have to round off, most likely with most answers, you'll have to round off your decimal, but that's okay. So for each one, we'll round it off to, let's say, 2 decimal places and see what you get. So on my calculator, I got 21 point, sorry, I'm squeezing it in here. It got 991148, and this number will never end. So we have to round it off to 2 decimal places. So I can see that there's my second decimal place. The number after it is 1. So that's my cutoff line. And because it's 5 or less, I don't add a 1 to the 9. So now the circumference, and because we're rounding off, we can put approximately equal to, because we have to round off. So the circumference for this circle is approximately equal to 21.99, and our units are centimeters. And that's it. So if I was to cut this line and draw it out and measure it out, it will come to 21.99 centimeters, or close to 22 centimeters. So it's not a very long circumference. Let's try the next one. Now, what's given to us? Is it the diameter? Yes, it is. We know that the diameter can be in any direction as long as it passes through the center. So once again, I'll write my formula. Circumference of a circle is pi times d. So circumference is pi times 8. And I'll put that in my calculator. And I end up with, my calculator's got 25.13274123, and I have to round it off to 2 decimal places. So because I'm rounding off, I'll put approximately equal to. So the circumference is approximately equal to 25.13. I don't have to add a 1 to the 3 because the number after it is 2 and it's less than 5. Or 4 or less. Okay, and my units are meters. Okay, so that one is our answer for the second circle. So that one there. Now, try the last one before I do it. And remember, always check, are we given the diameter or are we given the radius? So for this one, you can see we are given the radius. So I'm going to write that here. We've got R is equal to 2.1, just so I don't forget that it's not D, it's the radius. Now this is your choice. You can choose to use this formula, pi times D. Don't forget you've got to times 2.1 by 2 or double it. So if I get my calculator and I go 2.1 plus 2.1 or times it by 2, I will get 4.2, which is pretty straightforward to calculate. So the diameter is 4.2. Now it is your choice what you want to use. If you want to just stick with pi times d, you can. So what you would do next is you would have circumference is equal to pi times d. So circumference is equal to pi times 4.2. And if I put it in my calculator, times 4.2, I ended up with 13.1946 and so on. To round it off, I end up with 13.19. And my units are meters. Now, let's use so I use this formula here, pi times z, and I doubled my diameter. Let's just use this formula. Circumference of a circle is equal to 2 pi r, and see if we get the same thing. And I'm pretty sure we will. So instead of using diameter, I'm going to use this straight away. So circumference is equal to 2 times pi, and the radius is 2.1. And all I got to do now is put it all in my calculator. So 2 times pi times 2.1. And what do I get? The exact same thing. To round it off to 2 decimal places, or I should put approximately, it comes to 13.19 as well. And you can see how using this formula or the other one, it doesn't really matter because you're actually doing the same thing. But just be careful. If you're given a radius, you either double it and use this formula or just use this formula here. Okay, so we'll just go through some important points that we've covered. So in case you forgot to write something down that's important, the perimeter of a circle is called the circumference. It's pretty straightforward. The diameter is a line, so underline that keyword, that passes through the center of a circle and hits both ends of the circle. underline circumference. The radius is half of the diameter. So we know to get the diameter, we double the radius. Now there are two formulas that can be used to calculate the circumference of a circle, depending on whether you use the diameter or the radius. Okay, and you should have those written down. Now pi, so this lovely symbol here, is an irrational number. That's an important keyword and something you have to remember. Is an irrational number, which means its decimal never ends and has no pattern. And because of this, it cannot be turned into a fraction. So an irrational number cannot be turned into a fraction because its decimal never ends and has no pattern. So if you're not sure what irrational means, write this definition down because you will be using it in the future. We'll skip this second last point. We'll go to the last one for now. I should have pi here. I'll just write the word. So pi starts with 3 because any circle can fit 3 of its own diameters onto its own circumference. Okay, and so we can calculate the approximate circumference of a circle by simply going 3 times its diameter. Now, this point here, it's useful to know this. The closest fraction to pi is 22 divided by 7, or 22 over 7. And some of you may have encountered this before. And some students think that that is actually pi as well, but it's not. So the closest fraction, mathematicians have come across that it's close to pi, but we know it can't be pi because pi cannot be turned into a fraction. So if I push 22 divided by 7 on my calculator, I get this, 3.14 285714, and I can't fit any more. Now if I just get your calculators and I want you to just push the pi button and equals and see if it's the same decimal. So I'll get my shift pi. If I push my pi button, I get this, 3.14. So far it's looking the same, but then what happens? We got 1, 5, 9, 2, 6, 5 and 4. So we can see that, yes, this fraction is pretty close to pi. It starts off the same, but unfortunately it is not pi, so it's not exactly the same. But for a really close answer to the exact answer, you can use this fraction, just in case your calculator doesn't have a pi button on it. You can use 22 divided by 7 for a more accurate answer. So hopefully that has made sense, and we will try and do an activity outside to understand what pi is. Thank you.